Okay, so here we're going to do that. A question, okay, continuing from the previous class. Question 24 on your tuition note, page 89, 90. Okay, no test for this. You can write this portion. And here's the question, okay. On your tuition copy, you follow. Draw the ray diagrams for formation of image by a concave mirror stating the position, nature, and size of the image in each of the following cases. So let us take the case 1. Case 1 is what? Okay, you just draw here a line towards the left of your note, drawn in this manner, and mark here a point C. Okay, then you take your compass and then take around 6 centimeter distance. Now this is just a suggestion, okay, it doesn't have to be 6, but 6 is going to be convenient to use. That's why I'm saying 6, like this with your compass. Then put your center here at C and draw one arc. Arc means simply the incomplete circle. Okay, so here this we know is called the pole of the mirror, and half of 6 is, we know, 3, right? So you take 3 centimeter from your scale like this, 3 from 0 to 3, and add 3, which will be exactly in the middle. You mark, your F. So that will be your focus. So we will put our mirror like this. The reflecting side, the non-reflecting side here, the lines, always on the right, whether concave or convex, and the reflecting side should face to the left, so that your object will be to the left. Like this, we mean this is the reflecting side of the concave mirror, actual mirror, and this blue side doesn't reflect, cannot see your image there, right? So we have to put our mirrors this way so that our object is forced to be, in a sense, on the left. We can use like this also, but this way the object is on the right. We will not face the reflecting surface like that. Okay, so we will purposefully use like this, whether it is concave or convex. Okay, now here case 1 is, let us say the object placed at infinity. Means the object is very far away from the mirror. Okay, that means if this is the concave mirror, we are pointing it to a tree very far away from here, right, at a long distance. So that is the case for 1. So remember this, when the tree or the object is at infinity, then the rays that come out first initially, they diverge. Okay, means they spread out like this away from each other. But since they have a long way to travel, along the way, all of them become parallel to each other. Okay, that's how incident rays travel from infinity. When they reach the mirror, they become parallel. Okay, so let us say for this one, okay, just rub out your bar and put your F here for this case, because we need space below. Okay, now it is easier to draw like this in exam. Draw a small image first. So we'll draw the image first, A dash and B dash. So this is your image. Okay, then you see here, draw a line passing through the top of the image up to the pole like this. Okay, so this will be the reflected ray. Now we're drawing the reflected ray, which is not normal, like we always draw incident ray first. But as I said, for this case, it's always easier to draw the reflected ray first. It's going to be easier. Now, in your previous class, we have learned plane mirror and how reflection takes place from a plane mirror. It bounces back, and the normal is here, and this is called angle of incidence. The normal is a perpendicular line to the mirror. But in case of spherical mirrors, this normal is considered to be the principal axis. Okay, so the angle between this normal principal axis and reflected ray is called angle of reflection. This reflected ray, angle between the reflected ray and the normal principal axis is called angle of reflection, denoted by small r. Let us double dash it. Then look at the size of the angle, and we don't need to measure, but draw more or less around the same size of angle above, indicating the incident ray. So this incident ray we are drawing second. So now the angle between the incident ray and this principal axis normal is called the angle of incidence. We know that denoted by small I. So we are using the second law of reflection, which is this angle of incidence and reflection will be equal. So we are making use of the second law of reflection to draw these two rays right here. Now to get an image, we need at least two reflected rays. So as we said, this ray is coming from what? From the far away object like a tree. So there will be so many rays coming, but you can just take one. And we know that by the time it reaches the mirror, it will come parallel to the first one. So second incident ray also come parallel to the second one. You draw it like that. And after striking mirror, let this reflect and go to the top of the image, like this. So this is your incident arrow, and this is your reflected arrow, okay? Now before we proceed, let me remind us here that in your ray diagrams, if the pole P, F, and C are missing, your ray diagram will become meaningless, okay? So be careful with that. Okay, so here we have to write the things, so let us write down. Here we have to state the position, nature, and size. So write down image is dash, position is clearly exactly at the focus F. As you can see here, the image position is exactly at F. And clearly it is in front or left side. You see here, this is the mirror facing left, and the image is somewhere in front, see left side. This is called in front of the mirror. This will be called behind the mirror, but you can see here in front. So in front or left, any of these two you can use, or both also. At F, in front or left of the concave mirror. So that is the position of the image. Now how about the nature? Now you see here, the image is formed by the intersection of two real reflected rays. So since the reflected rays are real rays, the image will be called real, and it is ulta. You see the top of the tree is down now, so it will be called inverted. Okay, that is your definition for real images. Those are images formed by intersection of actual or real reflected rays. But in practical sense, which will make it more sense for you, that means here you see the looking glass that you have at home. When you stand in front, you see an image there behind, because that's virtual, right? And because the image seems to be there, but actually it's not there, so that's virtual. So that's why it's behind. But this one is not like that. That means if I put my focus to a tree at the far object, I won't see the image of the tree behind on the right side like the looking glass we have at home. It will be in front, and we cannot see until we bring a white piece of cloth or paper like this, and we move it back and forth. And when we are exactly here, then you will see the image of the tree on the paper or cloth, that is called screen. So unless we put a screen, real images cannot be seen. So real images are those images that are received on a screen. Otherwise we can't see, okay? So that is the nature of the image. Then here, size of image, if you compare to the real tree, which is quite tall, it's just a small image here, so it will be very small, which we can call it as highly diminished. Means so small compared to the real size of the object. So these are the three: position, nature, and size. Case 1. So we see here real inverted image formed in front or left of the concave mirror. Keep that in mind, okay? Let's go to case 2. Now let us say the object is placed. Now from very far away, we started from infinity. The object is going to be brought slowly closer to the mirror, okay? So next, you draw the line again like you did here. Draw the line, mark your C. This time you take only 4. 4 is more convenient now from the next 2, 3, 4, 5 keys. And just draw an arc. And mark the non-reflecting side as we agreed. Always on right, reflecting side left. like we have been saying here. See, we'll place our mirror like this with a non-reflecting side facing right, reflecting side facing left always, whether concave or convex. I'm repeating because that's quite important. Okay, so next, to do numericals also. So this is the pole, and half of 4 is 2, so take your scale and mark here from 0 to 2, you put it like this and mark there. 2 means exactly halfway you will be there. Mark that one as F. Without this P, F and C, your ray diagram will become meaningless, so don't forget this one. Okay, now object placed at infinity, now it's brought between infinity and C, closer. So between infinity and C, or you can simply say placed beyond C, means not at C but farther away from C, but not at infinity also, it's now closer. So draw properly beyond C, you draw an object. Let us say this is your object. Okay, and the top of the object, let us say, is this A, bottom is B. Okay, now we need 2 rays to form an image. We have said that in the first case. So every case will be like that. Okay, so from the top of the object, draw a ray parallel to the principal axis. So this is the incident ray. The first ray is called the incident ray. We learned this in the previous classes, right? So that is the incident ray. Now when it strikes the mirror, what will happen? The only thing that the mirror will do is reflect. That's the only job of a mirror, right? So it will reflect, and the rule is like this. It will go to the focus. So this is a new rule we are learning, so keep that in mind. And mark the direction of the reflected ray, don't forget that. Okay, so this is the rule. Remember again, a ray, incident ray parallel to the principal axis, goes to the focus after reflection. Always like that. It's a rule. Okay, it's a law. Then we need 2 rays. So from the top, let us say another ray is coming out, another incident ray, and it is going through the focus and touching the mirror. Let us say here the direction is from left to right. Now the rule is like this. A ray passing through focus becomes parallel to the principal axis, means parallel to this line passing through P and C. That's the principal axis, so this becomes parallel. So mark the direction of the reflected ray. Let me repeat again these 2 rules. A ray parallel to principal axis, go to the focus after reflection, one rule we have learned. Another ray, another rule, a ray passing through the focus F becomes parallel to the principal axis after reflection. So the 2 reflected rays here, first one, second one is meeting here. So where they intersect is where the image is formed. So here you draw, and then here mark it like this, because the first ray is also coming from the top of the object. Let us say this is a burning candle object you put. Then the top of the candle is down, because this is coming, see, from the top. This is also coming from the top. So this is the top of the candle image, top of the image, A dash and B dash. So this is your image. So we can write it now. So image position is where? Yes? Yes, that's right. It's between C and F. So let us write that. Image is formed between C and F. That's right. And still it is in front. You can clearly see that in front, which means it is on the left side of the mirror of the concave mirror. You can clearly see that, right? See here, this is the image, means the mirror is this here, like this, and it is on the left side, means in front, right? And it is exactly between, it is between F and C, or C and F. It is still real and inverted, same, and the size is smaller than the object, so it is diminished. This time it is diminished. So second time we're seeing here, real inverted image means in front or left. First one also like that. So it seems to be suggesting that every real and inverted image will be in front or left of the mirror. Okay, this is important for numerical. Let us go to case 3. Okay, case 3. Then the object is now placed. You're bringing it slowly closer. So where will the next one be? Yes, it will be at C, right? Placed at C. Okay. So let us do that. Now for this third case, case 3, in exam hall, remember this, it is easy, remember it is important to remember this, otherwise it becomes difficult to draw. For this case, mark here C, and don't let your C be up or down this time, maybe here, avoiding that line, okay, here, because both image and object will be there now. Then take 4 cm and draw an arc, and mark your concave mirror, pole, half of 4, take your scale again, half of 4, and mark it from 0, put a 0 at C, and mark 2, halfway it will be. And okay, sorry, for this case, as I said in exam hall, don't mark this in the beginning, if it becomes difficult if you do that, okay, in the beginning. Now, what you do is you draw here an object above C, at C, 1 cm up and 1 cm down, equal length, around, need not be 1 cm, but around 1 cm is a good distance. Then here, top of the object, bottom of the object. So this is your object. And then for this one, from advance, you draw the image also, A dash, B dash. So this is your image. It's easier to draw both in the beginning, okay? Otherwise it's quite difficult, becomes difficult to get, right? In the exam hall. So we need 2 rays, so from the top of the object, pass an incident ray parallel to principal axis. And mark the direction left to right, arrow. Now this arrow is not the light ray, this is indicating top of object. This is indicating bottom of, sorry, top of image. So you know this will pass through focus. But we haven't drawn yet focus, no need to worry. Just pass it through the top of the image. Brush it through the top of the image like this. And mark the reflected ray. Okay. After that only you mark here F. That's the easier way to do, okay, in the exam hall. Because teacher is not going to measure whether accurate or not. He's interested in you knowing whether where the position of object image is. You know all those things or not, you'll get full marks because these are not accurate diagrams. Okay, so we need to know in advance. Object at C means image also at C. So if teacher knows that, then there will be no problem. He's not going to check the accuracy because these are not accurate diagrams. So pass a ray through now, focus. We know the rule now. Incident ray arrow, don't forget to mark. And then this ray will become, we know now, we've discussed, parallel to the principal axis and brush to the top of the image. So these 2 reflected rays meet here, so the image is formed here. So now what would we write? When the object is placed at C, image is formed. Also exactly at C, and then it is in front or left side of the concave mirror. You will clearly see here on the left side, in front. Right side is called behind, okay? It is really inverted. And for the first time we're seeing size of the image is of the same size as the object. So this is the only case where object and image sizes are equal to each other, okay? So let us do the next 3 cases in the next video then.